In this video, we'll learn about types of organic compounds. Alkanes. What are alkanes? They are compounds contain carbon and hydrogen atoms with single covalent bonds. The molecular formula is CnH2n plus 2. If you substitute n is equal to 1, you will have C1 H2 into 1 2 plus 2 H4 CH4. This is methane molecule. If you substitute n is 2, you have ethane. Substitute n is equal to 3, you have propane. So here the suffix is n. So methane, ethane and propane. So this is a three-dimensional representation of a methane molecule. So this wedge-like bond represents the hydrogen atom is towards the viewer. This dash-like bonds represent this hydrogen atom is present away from the viewer. Or you can say this wedge-like bond is present. This hydrogen atom is above the plane. This hydrogen atom is below the plane. And what are alkyl groups? So alkyl group is formed by removing one hydrogen atom from the alkane chain. The molecular formula is CnH2n plus 1. So here the suffix change from A to OL. So if you take methane, if you remove one hydrogen, it becomes methyl. For ethane, it becomes ethyl. For propane, if you remove one hydrogen, it becomes propyl. So for butane, it will be butyl. So methyl, ethyl, propyl, these are all alkyl groups. So isomers of alkanes. What are isomers? Isomers have the same molecular formula but different structural formula. So this is the molecular formula of butane C4H10. But here two isomers. Okay. Two different structural formulas. One is N-butane, CH3, CH2, CH2, CH3. N refers to normal. Another one is isobutane. The IUPAC name is 2-methyl-propane. So what is iso here? Here if you can see, this is the first number 1, number 2, number 3, 3 carbon, right? So in this chain, the second last carbon has only one methyl group. The second last carbon has only one methyl group. This methyl group is called iso. So it is called isobutane. Or you can say 1, 2, 3. The second carbon has one methyl group. This is called 2-methyl-propane. Another molecular formula C5H12. This is pentane. Another structure is 2-methyl-butane. You can say isopentane. As I said earlier, the second last carbon has only one methyl group. It is called iso. So this is isopentane. So what is neo here? Neopentane. Here carbon number 1, this is carbon number 2, carbon number 3. The second last carbon has two methyl groups. Number 1, number 2. So this is called neo. So iso means second carbon has only one methyl group. Here the second last carbon has two methyl groups. This is number 1, this is number 2. If it has two methyl groups, that is called a neo. So this is neopentane, or you can say 2,2 dimethyl propane. So these are the three isomers of pentanes. It is C5H12. Properties of alkanes. C1, carbon 1 to carbon 4, they exist as gases. Carbon 5 to carbon 17 will be liquids. C18 and more will be solids at 298 Kelvin. Right? So alkanes are basically colorless and odorless. And alkanes are non-polar molecules. So they are non-polar because of a little difference in electronegativity between carbon and hydrogen. So here the electronegativity of carbon is 2.5. For hydrogen it is the electronegativity is 2.1. So the difference in electronegativity is 0.4. So it is very less. So their alkanes are non-polar. But if the difference in electronegativity is more, it will exist as a polar molecule. Okay. So here the difference in electronegativity is 0.4 only. So they are non-polar. The boiling point and melting point increases with increasing molecular weight here. Okay. So another point, alkanes are least reactive type of organic compound. So basically they undergo substitution type of reactions. Another interesting observation here, you can take here boiling point. So boiling point of N-pentane is 309 Kelvin, 2-methylbutane 301 Kelvin, 2,2-dimethylpropane is 282 Kelvin. So as the branching increases, the boiling point decreases here. You can see here. So this is a branching. Pentane, 2-methylbutane, 2,2-dimethylpropane. 2,2-dimethylpropane has two branches, right? So as the branching increases, the boiling point decreases. So what will be the reason? So here, as the branching increases, surface area of the molecule decreases, okay, which weakens the intermolecular forces. So less energy is required to overcome that intermolecular forces. So boiling point automatically decreases. Okay. So I repeat, as the branching increases, surface area of the molecule decreases, which weakens the intermolecular forces. So boiling point also automatically decreases. Okay. So next is alkenes. So alkenes are unsaturated compounds with at least one carbon to carbon double bonds. The molecular formula CnH2n. Here the suffix will be ene. First one, ethene, it has two carbons, then propene, three carbon, butene, then pentene. So we have double bond here, carbon carbon double bond, right? So properties of alkenes, carbon 2 to carbon 14 will be gases, C5 to C17 liquids, C18 and more will be solids. They are lighter than water. Again the boiling point and melting point increases with increasing molecular weight. Okay, because the surface area increases. Okay, with the molecular weight. So the strength of intermolecular forces also increases. So the boiling point and melting point increases. So this is a lycopene. This is one example of alkene. The molecular formula C40H56. So this lycopene gives tomatoes the red color. Okay. So lycopene is a carotenoid and antioxidant present in tomatoes and other vegetables and fruits. Right. So the lycopene gives tomatoes the red color. Right. Isomers of butene here. So there are three isomers here. Okay, so same molecular formula but different structural formula. They are called isomers, right? So one butene. So start numbering from here. 1, 2, 3, 4. Right? So the numbering should start from the carbon where we have the double bond, right? 1, 2, 3, 4. So the here number name is 1-butene. Okay, so the carbon which has the lowest number, you should give the name, right? So this is 1-butene. It is not 2-butene. So here 1, 2, 3, 4. If you start numbering from this side, so it is 2-butene. Or you can say 1, 2, 3, 4. So it is again same. So it is 2-butene. You should not write it is 3-butene, right? You should get the lowest number. So likewise here 1, 2, 3. So here 2 second carbon 1 methyl group is present here. So this is 2-methyl Okay, prop 1 ene, 1 propene, 2 methyl, 1 propene. Isomers of pentene. Okay, there are 5 isomers here. 1 pentene here. This is one. 1, 2, 3, 4, 5. Okay, so first carbon, second carbon, we have the double bond. So 1 pentene. So here suffix is ene, right? Here 1, 2, 3, 4, 5. So this is 2 pentene. It is not 1, 2, 3, 4, 5, 3 pentene. So the correct one is 1, 2, 3, 4, 5. So this is 2 pentene. This example 1, 2, 3, 4. So this is 2 methyl, 1 butene. Here 1, 2, 3, 4. Okay, so double bond is present between second carbon and third carbon. So this is 2 methyl, 2, 1, 2, 3, 4. So butene, 2 methyl, 2 butene. Here, so numbering from this carbon, right? Because we have the double bond here, not from this side. 1, 2, 3, 4. So this is 3 methyl, because on the third carbon you have the methyl group. 3 methyl, 1 butene. So these are the 5 isomers of pentene. So next one, alkanes, they are also unsaturated compounds with at least one carbon to carbon triple bonds. Molecular formula CnH2n minus 2. Here the suffix is yne, right? Yne. Suffix will be yne. So first two example, ethane, the formula C2H2, you can see the triple bond here, HC triple bond CH. Propine, C3H4, 1 butane. So you can number here 1, 2, 3, 4. So triple bond is present between first carbon and second carbon. So it will be automatically 1 butane. 2 butane, C4H6. 1, carbon 2, 3, 4. So the double triple bond is between second carbon and third carbon. So you have number 2 butane. Properties of alkanes, again C2 to C4 they are gases, C5 to C12 they are liquids, C13 and more they are solids. They are slightly soluble in polar solvents. Boiling point again higher than alkenes and alkanes. So the question is here, why alkanes are more acidic than alkanes and alkenes? Okay, why alkanes are more acidic than alkanes and alkenes? So we'll discuss the answer to this question in the next video. Thank you.